Add 8x to 2x and then subtract 5 from the sum. If x is a positive integer, the result must be an integer multiple of. Let's go ahead and do what they say. Let's translate these words into an equation or into an expression and see what we learn. So let's add 8x to 2x. That gets us 10x. And then subtract 5 from the sum. In other words, subtract 5 from the sum of 8x and 2x, so subtract 5 from 10x. The result must be an integer multiple of what? So what do we mean by an integer multiple? It means that this expression is some multiple of one of these particular integers. So for instance, it's a multiple of 2, a multiple of 5, a multiple of 8. Well, notice if I go ahead and factor out a 5 from the expression, I'm going to get 5 times 2x minus 1. Notice this, therefore, shows us that the expression is a multiple of 5, right? It's 5 times 2x minus 1. And there you go. So the answer is B. It's not going to be 2, 8, 10, or 15 because notice this isn't a multiple of either one of these, of any of these choices, right? It's not 2 times something. It's not 8 times something. It's 5 times this whole expression. Perhaps an easier way to do this, if you don't quite see the relation, is to actually plug in a number for x. So let's pick an x, given that x has got to be a positive integer. Fine. So let's pick, 4. So now we're going to add 8x to 2x. That's adding 8 times 4 to 2 times 4, which is 32 plus 8, which is 40. Now we'll subtract 5, and we get 35. And notice 35 is a multiple of 5, right? And it's not a multiple of 2, it's not a multiple of 8 or 10 or 15, but it is a multiple of 5. So at the very least, we can eliminate these choices and, of course, be down to 5. Perhaps if you had picked a different number, you might have gotten a multiple of 10 or multiple of 15, but that's okay because you just keep picking numbers until you would narrow down to 5. Either way, the answer to this one is going to be B.